All right, let's get started. What is software architecture design? For me, it's a process that starts long time before I write first line of code and ends when the application is decommissioned. So as an input to this process, we receive architecture drivers, functional requirements, architecture characteristics, technical and business constraints. And in the output of this process, we get the actual architecture. So the structure, architecture style, decisions, and design principles. So some static assets. Today, I would like to focus on the dynamic aspect of the architecture. So if the input to this process can change over time and architecture drivers tend to change over time, then the output of this process can change as well. And it doesn't mean just changing architecture decisions or design principles. We can decide to change entire architecture structure, adjust it to current architecture drivers. Welcome everyone. My name is Sulibor. I'm software developer at Bayer. And today I will talk about Modular Monolith and how it can evolve over time. In the agenda, we've got 3 sections. We will talk about various architecture styles. Then we will focus on Modular Monolith, the essence of this presentation. And in the last section, I want to share a few code samples from one of our projects in which we actually use Modular Monolith at the moment. All right, let's move on to the first section, in which I want to just give you a brief description of a couple of commonly used architecture styles. I will not go deep into them, just to make sure that we are all on the same page. Let's start from basics. Layered architecture. In this architecture, the application is divided into horizontal pieces, horizontal layers. Each layer has its own set of responsibilities, and in this architecture, it's strictly technical division. Each layer has some technical responsibility. So if you start introducing changes that are in the context of specific business feature, then it may get quite complex to start doing that in each of the layers where the context is so broad. But still, we get good separation of concerns and encapsulation in this architecture between layers. Important thing to note is that these layers form a hierarchical structure. So layers above always depend on the layers beneath. And we have a clear flow of dependencies. So when we handle, for instance, user request, we always go in this architecture from the top to the bottom. It applies to both flow of control in the application, but also to the dependencies in the source code. So layers at the top can depend on the layers below, but not the other way around. The next architecture that I want to mention is called clean architecture. It's a variant of layered architecture, but here the emphasis is put on making business rules independent of frameworks. So essentially, we put business rules in the center of this architecture, the important stuff, and then we surround it with less important stuff like application use cases, our infrastructure code in here, that layer is called interface adapters, and then finally frameworks and drivers. We get here all the good stuff from layered architecture, so separation of concerns and encapsulation between layers. But important thing to note here is the dependency rule. So it says that dependencies in the source code can point, must point always inward in this architecture. So outer layers can reference inner layers, but not the other way around. And in contrast to layered architecture, this direction is not always aligned with the flow of control. So let's imagine that I'm in the center of this architecture in my business layer, which is called here entities, and I want to call some external service just to evaluate some business rule. I cannot do that just by referencing a code that makes some remote HTTP request, because this is infrastructure code. It's an implementation detail, so I don't keep that code in my business layer. And I cannot just reference that kind of component directly. So in order to solve it, we just declare an interface in the center of this application. It can be interface or any other abstract type. And then we can simply use it to implement our business rule. But then we provide an implementation of that interface in interface adapters and wire it with the interface with some kind of dependency injection. That technique is called dependency inversion, and it allows to completely separate business rules from all the implementation details. It also leads to better interface segregation, and in general, when we use that technique, we produce better or more testable code. The next architecture that I want to mention is called service-based architecture. Maybe it's not that commonly used, but still it's important in the context of this presentation. It's defined in Fundamentals of Software Architecture by Mark Richards and Neil Ford. And in this architecture, we divide the application into coarse-grained services, each of which is a separate deployment unit. So by definition, this architecture is distributed. Each service, each domain service is deployed separately from others. We can further divide such domain services into smaller units called subdomains. Authors of this book that I mentioned call this architecture one of the most pragmatic architecture styles because it combines advantages of monolithic architectures and distributed. So imagine that in your application you have this part where you experience a high load of requests. So you can just put that part into separate domain service and, for instance, start scaling it separately from other parts. But in other areas of your application, you may need things like immediate consistency across multiple subdomains. So again, you can put all of these subdomains in a single domain service and use a database transaction that spans all of these subdomains. And that's how you can easily achieve immediate consistency. So it's very, very flexible and pragmatic architecture style. And the last architecture that I want to mention, of course, microservices architecture. In contrast to service-based architecture, here we use fine-grained services, so services with smaller responsibilities. We achieve good decoupling in terms of development and deployment, and the data is completely isolated between services, as you can see. We get great scalability and elasticity out of this architecture, but this flexibility doesn't come for free. It's a complex architecture style and has high overall cost of both development and then maintenance. All right, let's move on to the modular monolith. What's that? For sure, it's a monolithic architecture style. So it's just a single deployment unit. We bundle entire application code into a single package, deploy it in one go, and then run it in a single process in our hosting environment. So definitely it's a single deployment unit. But on the other hand, it's modular. What does it mean that it's modular? Module is very ambiguous term, so let's try to define what a module is in this context. Modules in this architecture are independent. Does it mean that they cannot talk to each other, they cannot be integrated? Of course, it's not the case. They can integrate with each other, but we should keep the number of integration points under control. We should basically limit them, isolate modules as much as possible. Each module should be self-contained, which basically means that each module is a vertical slice in our application. So it should contain all the code that I need to implement a single business feature or change that feature. So when I introduce changes into my application, I want to narrow down the context of changes. I want to focus just on a single module in the application and don't, start introducing changes to a broader context, like in a layered architecture where a single layer spans entire application. And the last attribute is that modules have well-defined interfaces which abstract the implementation details and allow to integrate with these modules. What are the architecture drivers that we should take into account when we consider using this architecture? So first of all, the complexity. Complexity is much lower compared to any other distributed architecture style. So in this architecture, in modular monolith, all the communication happens in memory, right? So when we integrate two modules, it's just a call in memory, a call to a function or method. So we always know the address of the other side of the dependency. The other side of the dependency is always available and the communication is secured. So we simply avoid entire group of problems, potential issues related to the communication over the network. Due to the same reason, we can usually achieve better performance using this architecture style, because communication in memory is much faster than communication over the network. I say usually because, of course, it depends. It's not always the case. And sometimes some areas of our application may experience high load of requests, and it may impact performance of entire application, all the modules. And that's how we go to the next architecture driver, scalability. In terms of scalability, modular monoliths are terrible. Let's face it. The only way to horizontally scale modular monolith is to just replicate entire service with all the modules. So if you just want to start scaling one module, one part of the application, then modular monolith will not do that thing. Then you have to take into account failure impact. So if you experience some error in one of the modules in your application, you have to be aware that that error may impact entire application process and in turn bring down all the modules in your application. So no failure isolation. And the last thing that I want to mention is that if you decide to use this architecture style, you commit to a single technology stack. So you just lose the ability of choosing the right tool for the job. An important thing that I want to call out about modular monolith is that it's domain-centric. So applications that use this architecture usually follow domain-driven design approach, in which we start the design process from defining the problem that we want to solve with our software. It's called domain. Then we divide that problem into smaller problems that we call subdomains. And in the next step, we use a technique called context mapping, in which we map these subdomains to our solution space, which in DDD is called bounded contexts. And then in the end, each of these bounded contexts can be reflected as a separate module in our application. Of course, this is oversimplified example where the relationship between subdomain, bounded contexts, and modules are always one-to-one. In real-life scenario, this can get much more complex, but just wanted to give you an idea how it works. The takeaway from this slide is that the good thing about modular monolith is that it forces you to start to think about modules and these vertical pieces of your application right from the beginning. So even when you start designing the application, you just have to divide it into modules. And it's just so much easier to maintain that kind of application that is divided into these vertical slices right from the beginning. All right, the last slide from this section, if you are about to remember one slide from this presentation, then please remember this one. I want to encourage you to at least consider using modular monolith the next time you start a new project. Of course, it's not a silver bullet, right? So you cannot apply it to every single use case. But still, I think it's worth considering. Every architecture decision, and I want to emphasize that, every architecture decision should be made based on your architecture drivers and your context. But if your architecture drivers don't force you to use any sort of distributed architecture, then you really don't have to use it just because you may need some attributes of distributed architecture in the future, or just because microservices are that popular nowadays. You can start simple. You can decide to use modular monolith. Divide your application into modules, vertical slices, and then when you are more familiar with your domain, when boundaries of these modules are well established and your architecture drivers start indicating that you may need some attributes of distributed architecture. Like, for instance, you need to start scaling, horizontally scaling one of the modules. Then you can migrate towards architecture like service-based. You can extract one of the modules into a separate service and start scaling it independently from the other part of the application. And if you need even more of decoupling, flexibility, because the project has grown so large and now multiple teams are involved in the development and you just need to decouple the modules, then you can decide to migrate towards microservices where each module is extracted to a separate service. So again, the fact that you decide to use one architecture style in the beginning doesn't mean that you have to stick to that architecture style till the end of your application. If your application is well designed, well architected from the beginning, you distinguish these vertical modules in your application, then it will be so much easier to start extracting these pieces when you really need that in the future. All right, and the last section of the presentation, in which I want to share a few code samples. We don't have enough time to give you full business context of the project that I'm working on. But for the purpose of this presentation, is enough to know that my team is currently working on a self-registration process for our customers. This is very early stage of that process. We will not get into details. But the important thing is that we divided this process into, this is our domain space, right? This is our problem that we want to solve with the software. We divided that domain into 3 subdomains called user identity, user registration, and notifications. Then we reflected these 3 subdomains as 3 separate modules in our application, our backend service. Only one of them at the moment is using the database, it's user registration. But in the future, if we need, we would simply distinguish separate database schema in the same database resource. All right, and that's how our modules are reflected in the source code. So we've just right under source directory, we've got 3 subdirectories for each of the modules. It's notifications, user identity, and user registration. In each module, we use clean architecture, but with different number of layers. Depending on the complexity of the module, we use either 3 layers or just 2. In user registration, which is our module that is handling like the core business logic of the process, we use 3 layers, domain, application, and infrastructure. But in 2 others, we just use application and infrastructure. And again, that's how it looks in our source code. When I expand notifications, I see only application and infrastructure layers. When I expand user registration, I see that extra domain layer here. We further divided application layer into even smaller vertical pieces that are called use cases. We follow the naming convention from clean architecture defined by Robert C. Martin. But you can also encounter names like application handlers. These are equivalent and used interchangeably. either use cases or just application handlers. And again, if I expand my application, I see all the use cases that I handle in this particular module. For user registration, it's approve registration request, create registration request, and so on. We group our use cases into, we distinguish two types of use cases, commands and queries. I cannot say that we use full-blown CQRS, command query responsibility segregation, because in the end, both of these use cases use the same underlying database model. But still, in our domain layer, we distinguished a group of classes that we call state. And these are simple classes with just a bunch of properties, no behaviors. And we allow our query use cases to use just these classes directly, because in query use cases, we want to query the data. So why not to just use the state directly? It's just about querying the data, right? We don't change anything. So we use that simplification. But when we handle commands where we want to change the state, we go always through our domain components, root aggregates and entities, which in the end modify exactly this, manipulate exactly the same state classes, but at the same time, they enforce business rules, right? So we can be sure that when the state is modified, it will be always consistent. And that's how we execute our use cases. This is one of the methods from our controller. By the way, in our infrastructure, we use Node.js. And this is a typical structure of a controller method. The controller method is called post. We accept two inputs, user ID and the request body. And we convert that input to the controller to either command or query. In this case, it's command, line 77. And then we pass that command or query to a component that is called command bus or query bus if we are handling queries. These components come from Node.js CQRS package, and these are just simple wrappers around observables and allow you to set up application pipelines. So add some extra behavior on top of the use cases that are handling commands and queries. And from these components, we get some result, and we just convert that to actual HTTP response, which is not included in this slide to keep it brief. All right, and that's how our use case declaration looks like. First of all, well, it's a class, right? First of all, it is decorated with either command handler or query handler decorator. Again, these decorators come from Node.js. And the decorators defines that this particular class, use case class, is responsible for handling specific command or query. So then when I pass that command or query to the query bus or command bus, the framework knows which use case should be executed, which use case is responsible for handling that input. And the other important thing is that use cases must implement either iCommand handler interface or iQuery handler interface. In this particular case, we also accept 3 dependencies. We always inject dependencies in constructors. And I promise the last slide with the code. This is a typical structure of a command use case. By the way, I didn't mention that in the previous slide. The interface that use case must implement iCommand handler or iQuery handler has just one method. It's called execute. So that's all what you have to implement there. And this is a typical implementation of such a method of a use case that comes from module in which we use the domain, the domain layer. So as you can see in the first step, line 29, we use a domain repository to materialize our root aggregate, in this case, registration request. Then we set some additional data on that request account in this case. But the important stuff happens in line 41, where we execute specific behavior on that root aggregate. In this case, we want to approve registration request, so we call approve method on that aggregate. All the important stuff happens there, like all the business logic, all the validation, invariants are enforced there. So use case is just responsible for orchestrating the domain layer, right? Materializing the root aggregate, calling specific behavior, and then saving the state. So if the result from the approve was successful, which we check in line 45, we just persist the current state of the aggregate and publish all the domain events that were that came out from that root aggregate. In the end, we return a result, which is then handled in our controllers. All right, that's all what I prepared for today. This is the list of additional of the sources that I used to prepare this presentation. Here you also have my email address, so if you have any questions or want to share your feedback, which is more than welcome, then please reach out to me via email. That's it. Thank you.